Hello and welcome to this short introduction to shapemath. My name is Michael Cornell and I'll be showing you the ropes. First, what is shapemath? Shapemath is a system of calculating math using shapes. Instead of thinking how two numbers add together, you think how two numbers fit together. It allows you to do addition, subtraction, multiplication, division, working with money, and converting different units of time. Let me show you an example. If you have the shape of a 3 in shapemath, which is this shape, and the shape of a 2, the 2 fits into the 3 and makes the outside shape of a 5. It is the outside shape that determines what the answer is. But we could combine together the 2, the 3, and the 5 and make the outside shape of 10. Because a 5 plus a 3 plus a 2 equals 10. You can also do more complex processes with shapemath, such as division. You can see how many times one number fits into another number without needing to use rote memorized times tables. For example, how many times 8 goes into 20? Here we have the pattern of 20. It's 20 because this is made up of two 10s. And we can see that 8, which is this shape here, fits into it 2 times. But not only can we see how many times 8 goes into it, but we can also figure out what the remainder is. The parts that aren't covered by the 8 are enough space for 1 triangles to fit into. So we can figure out that 8 goes in 2 times with 4 remaining. 2 times with 1, 2, 3, 4 remaining. Shapemath division is also capable of doing more complex division problems, such as problems out to multiple decimal places, but this is just a short introduction. And just because you don't need multiplication to do division doesn't mean that shapemath can't do multiplication. I'm going to show you an example of how to figure out one of the 2-digit multiplication problems that is involved in figuring out the times tables. But keep in mind that shapemath can figure out all the multiplication tables 1 through 10, which are the ones that you need to know because all the other ones can be broken down into the place value system. More on that later. I'm going to show you the example of 6 times 4. This is the pattern of 4 6s. They're 6s because there's a 5 and a 1, which makes 6. If the student can count by 5s, we would count the 5s and then count the 1s. It would go something like this: 5, 10, 15, 20, 21, 22, 23, 24. Or, if they can't count by 5s, we use a technique called rearrangement. We would take the 5s here and rearrange them into as many groups of 10 as possible. These two 5s combine together to make a 10, and these two 5s here combine together to make 10. So they would know that there was 20, two 10s, and then they could count onwards. So they have 20, 21, 22, 23, 24. Or they could rearrange all the different parts to make a complete pattern of 24. The 1s combine together to make the shape of 4 here. 24. Next, I'll show you one of the most popular things in shapemath money. Instead of simply telling the student or having them memorize that 4 quarters make $1, in shapemath you can fit 4 shapemath quarters into the pattern of 100 on a shapemath $1 bill. Let me show you. Here we have a $1 bill in shapemath. It has the pattern of 100 on it, which is 100 because it's made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tens. And this is a shapemath 25-cent piece, or a shapemath quarter. It's 25 cents because we have a 10, and a 5. And you can place 4 shapemath quarters onto this pattern of 100. See, 2 of the shapemath quarters, the 5s here, combine together to make another 10, so you have 50 cents. And you put 2 more into the pattern, and you have $1, or 100 cents. We also have a tab for bills, and you may have noticed that the rest of the world does not use shapemath money. So the student is transitioned to more realistic money, such as this. Now on to another aspect that is very popular. The shapemath program integrates very well with the place value system. This is because the place value system breaks down larger problems into a series of problems that are 10 or lower. This is the problem 49 plus 5. To do a problem like this, you draw arrows and move the different parts around. So first, we'll take a 1 off of this 5 and move it onto this 9 here. This 9 now makes a 10, but you can't have a 10 in this place value, so you have to X it off, because you've used it, and move it to the next place value, where it becomes a 1. And we circle it. Now the only thing left in this column is a 4. There we are. Now we can take this 1 that we carried and move it onto the 4. X it off because we've used it, and now we have a 5. And we're done with that column as well. So we draw a 5 down here, which gives us the answer of 54. But we always teach the student to write their answer also in Arabic numerals, so other people can read the answer that they've gotten. The idea behind the written form of shapemath you just saw is it allows them to use shapemath anywhere that they would be able to use regular Arabic numerals. This comes in handy for problems that are too large for them to do mentally. Now you may be wondering, what do I need to use shapemath? As you may already know, shapemath is a digital product. You can use it on a computer, Mac or PC, or a iPad tablet, as you just saw. We're able to get this high range of compatibility because we use HTML5, which is a cross-platform format. How is the system taught? Shapemath is taught through a series of video lessons that guide the student through the program. When you purchase a Shapemath subscription, you get over 14 hours of video lessons that stream right along with the web application. The video lessons allow the student to teach themselves independently and to go at their own pace. How much does the system cost? For current pricings, or just to find out more about shapemath, you can visit shapemath.com. While there, you can try out the free demo, which gives you access to the first tab of shapes, which are these shapes here, and access to the first shapemath lesson, so you can see if shapemath fits with your learning style. You can also call 412-527-6988 to speak with a shapemath representative. This has been a short introduction to shapemath, and thank you for watching.